Welcome back to Computer Science S75. So tonight's on MVC and XML in the context of PHP. And we'll also talk a bit tonight about the first project, Xero, whose PDF spec is now online. And we'll also talk about the CS50 appliance and about Linux and about a LAMP stack more generally. So what was MVC from last week? What was the purpose served by MVC? What does MVC stand for? I'll take anything. Yeah, Connor. Sorry? OK, Model View Controller. Good. So someone else. What does that mean? And what was the point of introducing this acronym? Yeah.
It means dividing all your files up into different stacks and layers. And
OK.
Getting things you use, for example, more often.
OK.
A single source and then using it in multiple views.
OK, good. So reusing of code is one of the motivations for MVC. Views, recall, had to do with the display of information. And so you could share code among your views, particularly for headers and for footers. And we didn't really dive into much detail yet about controllers or models even. So today we'll look a little more at the first two, views and controllers, so that you have some possible design patterns in mind when you tackle Project Xero. And also in tonight's section, which will focus predominantly on Project Xero, you'll be given some direction and some tips on what to do for that project. So just to set the stage, Project Xero is about pizza.ML, pizza markup language. And the motivation for this is as follows. Some years ago, there was a favorite pizzeria of ours down the road, a shop called 3 Aces, and unfortunately closed its shop, but we've hung on to its menu because it's a wonderful example of a messy data set. And the goal for this project is to actually implement your own e-commerce-like website for this pizzeria with which customers can order pizzas and subs and salads and the like. But the fellow who owned this shop, we've hypothesized, wasn't necessarily very technical and doesn't really need the overkill of a full-fledged database like MySQL, or certainly not Oracle or the like. And in fact, in terms of updating the menu, he is fine with something simple, even using something simple like TextEdit on a Mac or Notepad.exe on a PC. He also doesn't expect a huge amount of traffic, too, so he wants to just be able to run this site off of an old server that they were given under the desk somewhere. So in short, resources are few, the load is low, and so the motivation then at hand is to come up with a database design of sorts that can nonetheless support a pizza ordering website. So tonight we'll talk about XML. XML is a text file format, similar in spirit to HTML, but at the risk of oversimplifying, it's like a make your own HTML type language where you create your own tags, you create your own attributes. So this will be an opportunity to design your own representation of this pizzeria's menu. And you'll have to implement in PHP a system whereby users can visit this site and can navigate the menu and can add things to their cart, change quantities, delete things, and ultimately check out, quote unquote. And all of this will require some maintenance of state. So recall last week our discussion of the session object in PHP and cookies more generally. So being able to store things from page to page will be crucial for this particular challenge at hand. So more on that toward the end of tonight, but keep in mind that the goal will indeed be this pizzeria. So what's the context in which we're going to do this? So the CS50 appliance is just a virtual machine. Per the announcement on the course's homepage, we're going to post it very late tonight or by tomorrow morning once we finish adding a few final touches to what's going to be called version 17a. And the directions for this will be on the course's website. In the meantime, on the projects page on the course's website is the specification for the project. So you can dive in tonight and think through it, read through it, and then tomorrow you'll be able to download this and dive in hands-on. So the appliance is an installation of a Linux flavor called Fedora. For those unfamiliar, Linux exists in many different forms, Ubuntu and Debian and Red Hat and CentOS and all sorts of others. We happen to be using Fedora, which is an RPM-based system, but that's mostly irrelevant for our purposes because what really matters about the appliance is that it has LAMP and PHP and Apache and MySQL all pre-installed and configured for you, but still you'll have root access with which to tinker with the configuration files we've talked about thus far, http.conf, php.ini, and the like. And you'll find that it's a very natural real-world environment so that even though it's running on your own laptop or desktop, it's representative of most any commercial host or VPS, virtual private server, that you yourself might subscribe to. So you'll be able to experience exactly what you would if you were actually paying for some third-party hosting. So we'll do some more demos, and I'll walk you through some commands for those unfamiliar over the course of today. So here's a better picture than I certainly drew with my ASCII art last week of MVC. And the idea ultimately between MVC is that you have the brains of an operation known as a controller. And it might be one controller, it might be multiple controllers. And the controller talks to things like a model. Now for now, tonight, we'll largely wave our hands at the model, but we'll come back to this in the context of databases in particular. But for now, you can think of the model as being even for something like your XML file. So more on that to come. And then views is what handles the actual aesthetics. So once you have, for instance, come up with the data that you want to show to the user, typically you pass it as one or more arguments to this thing called a view. And the view is then rendered with that dynamically provided data. And we'll see a couple more code examples about this earlier. But really the key takeaway here is the directions of these lines. There is no lateral line left to right. And the idea, as will become more clear, is that your models, which again refer to databases, real world entities, student objects, pizza objects, order objects, and the like, should not have any direct communication with the display of that information. It's really the controller that should query a database or even an XML file, get some data, store it in variables, then pass those variables to the views for actual aesthetic rendering. And so we'll see, again, some concrete examples here tonight, and we'll revisit this topology over time. But first, some preliminaries. How many people here have used source control before, if you know what the expression means? OK, so a little bit of this, a little over here. OK, so a couple of you. We won't dwell too much on this in lecture because the project specification itself has some of the familiar commands. But source control is generally about keeping backups of your files in the form of differentials, changes from one version to another. If I put the question this way, how many of you, when writing essays, writing resumes, writing any kinds of documents that you want to make changes to, just so that you have copies of the old version, change your file from something.doc to something-old.doc, or something-july1.doc, or something-july2.doc, right? We all have probably adopted our own sort of versioning schemes just by making copies of files and renaming them. But what's the downside of this approach? Yeah? Yeah, if you rename the file, you've lost some of its history, and you can sort of figure out what change you made between version 3 and version 4 by opening them both up side by side. But you, the human, have to kind of figure out what changes did I make. If you're a bit more advanced with Microsoft Word, you realize that it has a track changes feature, which allows you to keep one file but record at least your most recent changes history. That's similar in spirit to source control. But if instead you've been doing it the old school, sort of intuitive approach of just recopying and renaming files, well, we can do better than this, particularly for large files. Because if you're making a copy of a file just so that you keep a backup of it around with a different name, you're literally duplicating all of the data between those files, which might not be a big deal for essays and whatnot. But if it's a video file, or if it's simply a very large essay with lots of diagrams or pictures, you could start churning through kilobytes or megabytes. So we can do better. So in the world of programming, there's this general notion of source control, which refers to the ability to write a program, for instance, hello.php, and then if you want to make a change to it, you can first commit the current version of your code to what's called a source code repository. And that repository is what essentially stores all of the backups that you yourself have decided to commit. You never change the name. Your file always stays as hello.php, but you can roll back in time through certain commands to say, actually, give me the version from yesterday, or 2 days ago, or a month ago. And the source control software that you're using figures out how to do all of this. You don't do any of the renamings yourself. So the way beyond the motivation for this being just to clean up one's backup systems, it's also very compelling for people to collaborate on code. So even though for this course you'll be working solo on your own on the projects, it's not unreasonable to expect that you're eventually going to work with a friend on some project, a colleague on some project. And so what version control also allows you to do is this. In general, this right-hand line here, the black one, represents what we'll call a master branch. A master branch is like the default repository to which everyone saves their code on the team. But you don't want to decide some night that, oh, I'm going to want to try to implement some brand new feature for my code. And you don't, though, think that it's just going to take a few minutes. It could take an hour, it could take a day, it could take a week, a month. So you don't necessarily want to start writing changes and then pushing those changes to the repository if your changes are only partially complete, right? If your code is broken, it's not going to really hurt you, but you don't want to break the entire project for everyone else. So what source control allows you to do is to fork off what's called a branch. So on the left in yellow here is what we might call a development branch. And any developer, yourself included, can create a separate branch, which you can think of as a copy of the main repository. But you can make all of your changes. You can push changes to the server, but they stay separate, a separate branch of the tree, so to speak. And only once you have decided, you know what, I finished this feature, I've correctness tested it, everything is good, then you want to merge it back into the so-called master branch. Then you can actually do exactly that, a merge from yellow to blue, at which point everyone else has access to your feature. So in short, not so applicable, this branching for our purposes in the course, since again you'll be working solo, but that's yet another feature of this. So source code control is incredibly common in the software world these days, and perhaps one of the most popular tools is something called Git these days. Now, for those familiar, Visual Studio in the Windows world has source control built in, and it just comes with Visual Studio. There are other tools out there like CVS and RCS and SVN, which you might have heard before. All of those are rather dated these days, and rather what's gotten more popular are things like Git and Mercurial and Bazaar. These are all tools that are distributed source code tools. And what this simply means is that you have not only a central server to save or to push all of your changes to, you also have a local copy in your own directory. So it means you can save different versions of your code in your own laptop or desktop without pushing them to the server, or you can also push them to the server. This is in contrast to things like SVN, which was perhaps up until recently one of the most popular tools for version control. The problem with SVN is that there's only a central repository. If you want to say, oh, I want to make a checkpoint here of sorts, and I want to save this version of my code, if you're sitting on the train or you're near Starbucks with no internet access, you can't do that because there's only a server. So these distributed tools like Git, Mercurial, Bazaar are definitely the way to go these days, since you have the best of both worlds. So here's a quick review of commands that will be repeated in Project Zero's spec. And we're trying to introduce this really for your own benefit so that, frankly, in the middle of the night, when you're chasing down some bug or you're trying to implement some new feature and you realize, damn, that was a really bad idea. I just broke my entire code. All you have to do is run a command like git checkout, and you'll roll back to the previous version without having to undo manually all of the changes you've made. But the general workflow is as follows. Either a code repository already exists in the world, and you, so to speak, clone it. And then you get a copy of it, and then you can proceed to do your work there. For our purposes in the course, you're not going to clone an existing repository because your project doesn't exist yet. Rather, you're going to create an empty directory, as I'll start to do tonight. You're going to run a command like git init, which will initialize that directory as being for a source code repository. Then you'll type git add, which will add files to that repository. And then you'll run git commit, which saves that checkpoint, so to speak. And we'll do this once ourselves. And then git push, meanwhile, is a little different. Git push, where do you think it pushes the code to, if not your local repository? Yeah, exactly, the server. So where is this server? We'll come back to that in just a moment. Git pull is the opposite of that. So if you are using a central server, you can pull changes down, which is useful if you own multiple computers and you want to work on this laptop, but then the next day at work you want to work on another computer, but you don't want to have to put your code on a USB drive or something silly like that. You can just run git pull on the second computer, and that will copy down the changes you pushed from the first computer. And Git Branch refers to this idea of branching that we discussed via the picture a moment ago. So where's this central server? So what we'll encourage you to do in the spec is to actually sign up for an account on this free service. So Bitbucket is a freely available service that allows you to create Git repositories, both public and private. Public generally refers to open source software that you want to make available to the world. The biggest example of this type of site is GitHub, if you're familiar with them by name or by practice. What's nice, though, about Bitbucket is that even though they're not as popular, they offer unlimited free and private repositories to people associated with the university, whereas GitHub charges for private repositories, at least for a non-trivial number. So we'll encourage you to do this so that you have a central place to store your code, not only for the semester, but really for posterity, but particularly since it'll let you keep your intellectual property private. But more on that in the project's specification. Any questions? So if I were to ask, What are two upsides of using source control? Sort of quiz-like. Can you give me one or two of them? Yeah.
If you break something, you can roll back to something they had before.
Good. So if you break something, you can roll back to a version you had before, or?
And all renaming is done automatically for you.
Good. So all the renaming, or all of what would be the renamings of files is done for you, sort of automatically, so that the file names never change. And how about something else, even though it's not as applicable to the course?
If you store things on a server as well, if your laptop breaks, you're still going to have
Oh, so that's another one. So the ability to push to a central server means if your laptop breaks or you're just elsewhere on a different computer, you still have access. Oh, this is good. We're breaking two. Yeah?
Easy collaboration.
Yeah, easy collaboration as well. So especially after the course, if you dive into some project and you want to work with a buddy on it, this is the way to do it, whether with a public or private central repository using a service like Bitbucket, GitHub, or the like. All right, so excellent. More on that in the spec itself. So this notion of MVC, how did we get to this point? Well, let me go ahead and pull up one of last week's examples where we left off and go to Lecture 2 source, which gave us these examples here. Oh, so actually, let me take a step back since I'm now inside of the environment of the appliance. So the CS50 appliance, again, is this virtual machine. It's an installation of Linux that you can run on your own Mac, on your own PC, or even on your own Linux computer if that's what you're running. And what I simply did on my Mac is I opened up a program a moment ago called VMware Fusion. VMware Fusion is a hypervisor, and a hypervisor is a program that lets you play, or that is run, virtual machines like the appliance. For the course, we have site licenses for VMware Fusion if you are a Mac user, and there are instructions in this on the course's website on how to access this when you download the appliance itself. For PC users, Windows or Linux, there exists a free version of this same tool called Vmware Player, which will allow you to run the CS50 appliance and all sorts of other appliances that people make available as well. So I ran Fusion. I imported the appliance by going to File, Open, essentially. Again, more on that in the actual instructions. And then I double-clicked it, and Linux booted up. And I simply have full-screened it here so that we can see everything within the scope of just one window. And it looks a little familiar to Windows or even Mac OS. We've got a menu here at the bottom. We've got some icons to common programs here, among which is a terminal window. Terminal window we're going to start getting acquainted with all the more. And this is sort of your old school style DOS prompt, command prompt, where you can type individual commands. But this is very much where you would live typically in the web world when setting up a server or uploading files, when you don't have, for instance, a GUI that some web hosting company provides you with. And there's also a text editor, Chrome, and more down there. So let me go ahead and do this. Let me go ahead and open up a terminal window by clicking the little black icon. And that gives me a window that looks like this here. And you'll notice that my name, and your name soon, is just John Harvard. And I am logged into the appliance. And in parentheses there is a tilde. And those familiar with Linux, what does the tilde represent? Okay. Connor, Axel? Exactly, the home directory, so to speak. So every user on a Linux computer, and also Mac OS and Windows these days, has a home directory. And the home directory is just where you put your stuff. On a Mac, it's called your username. On Windows, it's also called your username. And it's usually in /users on a Mac, or in documents and settings on a Windows computer, and the like. Same idea. So inside of this appliance, we have our own home directory, inside of which might be 0 or more files and folders. So I'm going to go ahead and type a quick command here to get us up and running on the web. But first, let me do this. Let me open up Chrome inside of the appliance. And Google comes up here by default. But instead, I want to go to http://localhost, just like last week. And what does localhost refer to exactly? What does localhost refer to? Yeah. Exactly, whatever is actually on the server. So I'm inside of the appliance right now. So localhost is, as the name implies, the local host, the local computer. And I go ahead and hit enter here, and recall that we did this last time, hello world, which I tossed into that default directory known as var /html. That's simply where on many servers files go by default, but this wasn't much of interest. It was just an index.html page. So let's instead now navigate our way to /tilde/jharvard, also like we did last week, and hit enter. But this time, this week, I've undone a lot of the changes we made last week so that we can start fresh and walk through the process of getting this set up. So this is bad. jharvard was /jharvard was not found on this server. So John Harvard has no website. So what directory is probably missing in this case that would explain why John Harvard has no website? Yeah. Yeah, so if I do an ls here, notice that I have a few directories in my home directory by default, one of which I downloaded in advance. I've got desktop and downloads, just like a Mac or PC these days, logs, which happen to refer to web server logs, and source, which I downloaded in advance for lecture. It's some pre-created lecture examples. But I'm obviously missing public HTML. So let's create that. I can do this in a couple of ways. The sort of real technical way to do it is mkdir public_HTML. This is just a convention that many Apache web servers use for the default directory for a user's homepage. You can change this to anything you want if you edit httpd.conf, but this is what, again, is the typical default. So we'll play along, and I'm going to go ahead and hit enter. Now, just to be clear, let me go ahead and minimize my terminal window for just a moment. If you're more comfortable in a GUI, realize I could just do this. I could double click on home, and that would open up a more familiar file browser. Then I can do something like file, create folder, and I could have done something like this. Create folder, public HTML, but you should get comfortable with the command line, since ultimately it would be much more powerful and where you sometimes need to be on a web server to configure things. So now if I type ls for list, I see public HTML. So now how do I open public HTML or navigate into it? Yeah.
Change dictionary, CD.
OK. Sure, close. Change directory, so cd public HTML, and you'll be able to type faster than you think thanks to keyboard shortcuts. So if I start typing pub and then I get a little bored typing it out, you can often hit tab to do what's called tab completion, which will just save you time on a Linux computer. Then I'm going to do ls for list. There's obviously nothing in there. So now I'm going to go ahead and type genie index.html. And this is going to open up a text editor that can be used for all sorts of languages, one of which is HTML. And let me go ahead in the tab that opens here, do doc type. HTML, and notice it's going to do some tag completion for me. Head tag, let me go ahead and do a title tag now. Inside of that, hello world. Now let me go down here and do a body, and hello world. Save this, and now let me go ahead and close this. And now notice, once I'm back at my command prompt, if I do ls, I see index.html. So let's see what the result here is. Now let me go back to my browser. Let me go back to the same URL, /jharvard. Do I need to do this? Whoops. This? So no, because again, because of a setting in httpd.conf, the default is assumed to be index.html. Or if you're running PHP, it will also look for index.php, as well as a couple other file names. So now I hit enter. Damn, I did something wrong. So first of all, what is the HTTP status code in question here? Yeah. 403. It's barely visible in Chrome these days, but if you look at the tab up top, you see 403. 403 means forbidden, which has something to do with file permissions, so I screwed up somewhere. So let me go back to my prompt. And how do I go about diagnosing this? Let's not solve it yet. What did we do last week to diagnose this? Yeah.
ls-al.
Good. ls-al. And this will show us a couple things. A will show us all files, including what are called dot files, which are simply files whose names start with a period. And those are just generally hidden by default. They're not really hidden. It's just by default, ls won't show them to you. So it's a common convention. And now here we have on the left, because I did L, a long listing. So besides seeing index.html and dot, I see the permissions for each of those directories. What are the permissions for index.html right now implying? Yeah. Exactly. Only I am allowed to read and write the file right now because you only see an RW on the very left. And recall that the leftmost R and W and X, if present, refer to the owner. The next triple, R or W or X, refers to the group, which in my case is going to be students, because John Harvard's supposed to be a student. And then the last three refer to whom? others, so everyone else in the world, which is pretty relevant in the world of the web because you're obviously trying to get other people on the internet, in this case even yourself on a browser, to view those files. So we need to give more than just me readability to this file. Not writability, but readability. So does anyone recall the command for doing this last time? Yeah.
Chmod a plus r and then file name.
Good. Chmod for change mode, a plus r for file name, and followed by the file name. Enter. ls-l now shows me, indeed, an R for everyone, including my group. My group's not really that relevant, but my group is a subset of the whole world, so that's fine as well. Now, because you'll see it online, let's do this slightly more technically. Let me undo that and say a minus R, and now do -l. And now, actually, now I really screwed up. Now even I can't view it. So chmod u plus R for index.html, and now I have my readability back, U for user. So let's do this a little more technically so that you've seen it before. I'm going to go ahead and open up a little scratch pad here, text edit, just so we have a place to see this. And let me go ahead and do this. So we just did a plus R, and I also did just now u plus R, and so forth. This is a nice convention, but it would seem to allow you to toggle just read or writability on a given group, yourself, your actual group, or the world. We can actually be a little more powerful here. So let me actually go back to a listing that looks like this. drw hyphen, 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 and then often a period there. So the D denotes what, typically? Directory. So I'm going to get rid of that now that we've seen it because we're talking about a file. So this is what we saw a moment ago when we got forbidden. Now the first 3 hyphens that follow are for the owner. The next 3 are group, and the last 3 are everyone. All right, so that's just a recap of where we started. But it turns out that I could have accomplished the same thing with chmod 644 index.html. 644. Well, where does it come from? Well, turns out that there's a little cheat sheet here. 4 typically denotes R, 2 denotes write, and 1 denotes X for executability. So these are what are actually called octal numbers for the following reason. If you add these things up, 4 and 2, obviously what do you get? Nothing technical about this. You get 6. So why does 644 represent the exact same string that we created earlier with these shortcuts like a plus R and u plus R and the like? Well, 644 refers to first, this 6 maps to these 3 hyphens. This 4 maps to the next 3 hyphens. And the last 4 maps to the last 3 hyphens. And so 4 means readability for everyone, 4 means readability for my group, and 6 means readability and writability for me. And it's octal notation because you can count up as high as 7 if you add all of these numbers together, 4 plus 2 plus 1, and the lowest number you can count from is 0. So we essentially have a range of 0 to 8, a range of 8 total values. OK. And actually, you want a really geeky aside? Why does this actually work? These hyphens are actually placeholders for bits. So in fact, if you want to give someone writability, the whole world, rather, readability, you would do this. You would set that to 1. If you want to also let the whole world write your file, you would do this. And then you would leave this, rather. Let's say you just want to give the whole world readability. Well, what's this number in binary if you convert it to decimal? 4. Right? So this is the 1's place, this is the 2's place, this is the 4's place, if you know binary. So this represents 4, which is why readability is represented by 4, writability is represented by 2, and executability is represented by 1. OK, random technical aside that you don't need to understand at a low level, but hopefully now just with these numbers you can express any set of permissions that you actually want to. So let's actually summarize with a quick cheat sheet now. So for my HTML file, I wanted 644. However, 604 would work as well, but generally just keeping the last 2 the same is fine. What other types of files would you probably want to be 644? In other words, world readable, but also writable by you. What kinds of files in the context of the web? Surely there's something else. Yeah. PHP, so good thought, but we actually don't need our PHP files to be world readable because only the web server needs to be able to read our PHP files in order to interpret them, after which it will spit out world readable HTML. So in fact, for security, and recall our discussion a couple weeks ago about SU PHP, substitute user PHP, in the interest of security, PHP files should really be on a well-designed system 600, so that only you can read and write them. But that's fine, because recall that a piece of software like SU PHP runs as you, so the implication is that 600 is fine. So by contrast, what kinds of files also need to be 644? Yeah.
All the other things you would reference in your HTML.
OK.
JavaScript and everything.
Good. So all the other stuff. So 644 for this, CSS, 644 for this, JavaScript file, 644 for this, pings, 644 for this. What about a directory? What should a directory be? Yeah.
Readable by the world, but not writable.
OK, so good thought. So readable by the world, but not writable. So something like 644, so readable. So it turns out this doesn't work for directories. So directories are sort of conceptually different from files, certainly. And with directories, in order to do something with them, there's two permissions involved. One is readability. Can you see what's inside of it? So that's reasonable to want. But the other is executability. Can you even physically open it by double-clicking on it, by typing cd? So it turns out that executability in the context of directories is necessary if you want to let the world into that directory. So I would actually refine our definition here. And besides just giving everyone executability, which we might be tempted to do by just adding 1 to each of these numbers, because recall that 1 represents executability, I'm going to propose that, you know what, the world needs to be able to get into a directory, like a subdirectory in my web server, but they don't need to be able to poke around and see all of the files. If they know the name of the file and it's readable, fine. But I don't want to give them what's called a directory listing, which shows them all of the files in a given folder. And for that, you would do 755. To not do that, you would do 711. So in general, this cheat sheet that we just made here is this is a pretty exhaustive list of the relevant file formats that we'll be using for something like Project 0 or 1 or 2, and as well as for directories. There's exceptions, but this is a pretty good rule of thumb. All right. So back then to where we left off here with MVC. So last time, let me go ahead and unzip some files that I just downloaded. So last time, recall, we had these directories. We had frosh.im's examples, we had some login examples, and we had MVC. And recall where we started with MVC. Let me go ahead and open up index.php for MVC version 0. And notice that this was simple, but there's no programming logic whatsoever. Even though this is called index.php, there's no PHP code in it. And that's fine, but it's just raw HTML. But recall that this website, let me go ahead and pull this up. Let me go into jharvard. And here's a difference. So now we're in lecture. And frankly, I'd kind of like to be able to browse the directory so I don't have to guess or remember the names of all of the files we've created. So let me go back here to my public HTML directory and do ls-l here. And let me make public HTML 755. Because when I do that, now watch when I reload. Whoops. Now I'm getting an error with index.html. Let's actually get rid of index.html and reload this. Now I get the directory listing. That's 755, when what we saw a moment ago was not. That was 711 or 700. So now I'm in MVC. Now I'm in version 0. And voila. This was the incredibly underwhelming website we started with last week using just HTML. But what was the problem? Well, if I click on lectures, this leads me to a file called lectures.php. And if I look at that file at a prompt, let me go ahead and do that, MVC 0. And let me go ahead and open up lectures.php. Notice that this file looks awfully familiar. Right? It's a little small, so let me zoom in. There's no PHP content in here either. It's pretty much a copy and paste, but I changed what the menu was. Then when you click on lectures and get to lecture 0 and lecture 1, well, what did those files look like? Pretty much identical. In other words, we started with a very clean, a very simple site, but a huge amount of copy paste. And what's the downside of this approach of just doing each page from scratch? Let's pick on this design a little bit. Yeah, Connor. Exactly. If you want to modify the site, even some silly aesthetic like the title or the color or something like that, you have to go through and edit every file, which it's not a big deal as of last week. There were 4 files. But what about when lecture 2 comes out and lecture 3 and lecture 4 and 5 and 6 and 7? Now we have a whole lot of files that we actually have to edit. What else is bad about this? Yeah. Yeah, it just takes up more space. And even though, disks are cheap these days, this is just wasting space, really, for no good reason. It takes more time, arguably. You minimally have to copy and paste the previous code or rewrite it from scratch. And yet the only content that's been changing, really, has been the menu here, the unordered list, and the title of the page. Everything else in this example thus far has been structurally identical. So we can do better than this. And so we progressively built up from this. So let's do a quick recap here. Let me go into version 1 and recall that version 1 did something a little different. And we don't need to look at the actual code. If you recall this quick summary in the README, what did we introduce here in terms of the files that was compelling? Well, we had this, yeah.
You stored the header and the footer.
Yeah, so we factored out the header and the footer, the HTML tag, the title tag, the head tag, and all of that. We had factored out the close body tag, close HTML tag, so that at least then we were only requiring at the top of the file the new content. So let me do that. Let me open up index.html now, and let me just do this at a command line just for time's sake. And now this was index.html. No redundancy whatsoever. This is all fresh content, and we've additionally required header.php and footer.php. And similarly, do all of the other PHP files include those particular header and footers that I want the user to visit. So this was better, but what was not perfect about this? Version 2 got even better, 3 got even better, 4 even got better. We went through a few of them. So what were some of the faults of this earlier design?
You can't choose what, say, something in the header is, like the title.
Exactly. Right now, if I'm requiring header.php, whatever is in there is what's going to get spit out. So I've presumably hard-coded one title for the whole site. There's no dynamism, at least to the stuff that I've factored out. So that's kind of a step backwards. I've paid a price for this dynamism by losing the ability to at least customize the title. So that seems a step backward, but how did we fix it last Monday? How did I give myself back the ability to control the title dynamically? Yeah, I used a function instead. So instead of using require, which is a built-in function in PHP that does exactly that, it includes or requires that file right then and there, I instead wrote my own function called render header and render footer that also took, in addition to the name of the file I wanted to render, header or footer, it also let me pass in what data type?
Variable.
A variable, but what type of variable? An array, exactly. And it was an array, an associative array at that. And let me go in here. If I open up now version 2's example, whoops. Yeah, this is it. Version 2's example, it takes an array as its argument and specifies that the title key should have a value of this. So that now I have the ability to change the values of variables inside of that header. Because if I look at the render header function, let me go ahead and do this. Let me go ahead and open up helpers.php, which is the file in which these are defined. Notice that they work fairly simply. They take an argument called data, is the parameter name here. It then extracts data and then requires the file. So the only one that should be obvious right now is this last line. Require header.php requires header.php. What did the previous line do? What does extract do? What did extract do? Yeah.
It actually takes the key value pairs out of the array and makes them into variables that you can use.
Exactly. It takes the keys value pairs out of the array that was passed in and just makes them actual local variables. So if you had a key of title, you now get, after calling extract, $title as an actual variable. Now why? Who cares? Well, if I look at my header.php file, notice that it looks like this up here. This is nice and simple with the title. Now, if I didn't do extract, that's not a key ingredient here. I could still access things, but instead I would have to do this, data, quote unquote, title in square brackets to get that key back. So why do you think I called extract in the first place? Why bother calling extract? If you had to guess, I'll take guesses. Okay, if you think you know, okay, yeah.
Simpler.
Yeah, that's good. Okay, 1 point. Yeah, honestly, it's the simplicity of it. So one, I just didn't want to type $data, quote unquote, all over the place because it's just not necessary, especially if I've created these local variables within the function. It should be sufficient to just type their name. Yeah.
You've also just defined one key value pair.
Oh, in this case, I've just defined one key value pair, so it's a little silly to bother indexing into an array. But even then, if I had more key value pairs, it really is just the simplicity again that appeals. And what was your name again?
Me?
Yeah.
Isaac.
Isaac, that's right. Sorry, I forgot. Yeah.
Also, if you ever change data, you'll have to go through and change all of these arrays.
Yeah, so that's a fair point. If for what maybe it's more of a corner case, but if you ever change the name of that local variable, now you have to change it everywhere as well. Sure, that's reasonable. So just a little bit cleaner. But let's resolve one other open question here. If we go back to the render header function, what is the deal with the equal sign and the empty array function call? What's that doing for me? Yeah.
Just creating an array?
It's just creating an array when?
When?
Or under what circumstances? Isaac?
Taking an argument.
It is taking an argument, and that argument's called data. But if I'm passing in an array, why am I saying equal sign array? Yeah.
If it finds that data doesn't have anything, it creates an array that's completely empty inputs for data.
Exactly. If I call render header without any arguments, which I might if I just don't need to pass in any arguments, and in fact that happens with render footer, I at least want $data to be of type array so that when I call extract, extract doesn't freak out because I've passed it some null value. Extract expects an array. So this is just a one-line clever way of ensuring that I'm passing in an array, because otherwise I would have to do something like if is array data, then call extract. And it's fine, totally correct and reasonable, but I can do it a little more elegantly by ensuring that data itself has a default value. So the equal sign just implies a default value there. All right, any questions on those? No? All right, so how much further did we go? Well, in version 3, we did something a little bit different, but now I still have footer.html, I still have header.html, footer.php, header.php, I still have helpers.php, but there was an opportunity for refinement here. Before, in the previous example, I had render header and render footer. And why is that arguably not the best design? Yeah?
Well, you could just do one function called render and then pass in what you want to render.
Exactly, right? So this isn't horrible, but the moment I introduce like a render middle or a render top right function, or more increasingly specific rendering functions, feels like there's an opportunity to factor that code out and generalize it as just a generic render function. So recall that in version 3, we did exactly that. In helpers.php, I just trimmed my code, added a couple new features here so that render now takes 2 arguments, the name of the template, so to speak, to render, the view, so to speak, and then it renders that particular template by passing in the data that was given. So a little sanity check here. First, I'm figuring out the path to the file. And why am I doing this first line? $path equals template.php. Why not just force the caller to specify header.php, footer.php? Yeah.
Well, to save space, it's easier to type render header instead of render header.php.
Yeah, exactly. As simple as that. Rather than saying render header.php, it's just reasonable to just want to say render quote unquote header. What else? If I ever change the languages that I am using for my templates, for instance, I want to support a templating engine. There exist things called Smarty. There are other templating engines that give you all sorts of functionality in your views. We're not getting there yet, but it'd be nice if I at least can support different types of templates and let the function figure out what they are. So in short, I'm just checking to make sure that the path then exists after appending the .php, then I do the exact same thing as before. So we then clean things up ever so slightly further. That was version 3. If we go into 4, notice what we introduced this time. Why did I introduce these subdirectories here? I claim that it's an improvement by organizing things in subdirectories. But why is this compelling? Yeah?
I don't know exactly if this applies in this example, but you should really keep all your files in other directories that the client can't visit directly.
Exactly. So this was a step toward a better security model, to be honest. This isn't all the way there. This is only a half a step toward it. But I've organized now my templates into literally a templates directory. This would often be called a views directory as well. And the motivation there being the user should never really visit footer.php or header.php directly. Why? Well, they're going to get a partial page, either the top or the bottom and nothing else. So I just don't want them visiting that in principle. And then helpers.php, similarly, they don't want them visiting that file either because it just has helper functions. It's not going to actually spit anything out. And worst case, maybe I have some passwords or something in there, and I don't want to run the risk of them visiting that file directly. So I'm going to tuck it into a directory called includes. Now, this does not necessarily protect us fully. As an aside, recall that Apache and other web servers support configuration files inside individual directories. So I could, if I really want to be clever, have an htaccess file in my directory, in my public HTML directory, that says do not let the outside world into includes or the templates directory. But the risk there is that if I screw up, if the webmaster disables htaccess files, all of a sudden that protection could be lost. So a better approach is what we did half a step later. So that was version 4. And in version 5, what I instead did was was this layout. I created a whole new level of hierarchy whereby I still had my includes folder. I still had my templates folder. But what's different this time versus the previous example? Yeah. Exactly. Now I have an HTML directory, the idea of which is that only the web accessible stuff, including not just my PHP files, but my GIFs, my JPEGs, JavaScript, CSS, all the stuff that has to be public goes into that directory. Or not even necessarily public, has to be uniquely addressable via a URL in the browser so that the user can actually visit it. Now recall last week our discussion of http.conf. So recall that that has a directive called document root. So let me go ahead and open that, etc httpd http.conf. And let me scroll down to document root. Recall this thing that we looked at last time, where we had this directive here, var www html. So this is that document root we keep alluding to. This is why we had to put that silly little index.html in that folder last week. Well, OK, how do I now make this particular example accessible on the web? Well, I would have to do something now like document root /home/jharvard/public HTML/HTML. But this isn't quite right? Because if I do this for my document root, specifying that this HTML directory is the one that should define the base of the web server. You can't go any higher than that. That's what the document root does. It means you can go to that folder and anything in it, but you can't go higher. And that's exactly the protection we want. I'm kind of being an idiot here, though. I haven't really achieved what I want to achieve. Why? Yeah.
By default, it's a public HTML.
Right. So by default, public HTML is literally public. So you can create as much hierarchy inside of it as you want. The whole world can still access the contents of that directory. So unfortunately, when you're on a shared web host that gives you just a home page with a tilde involved in the URL, like ~jharvard, you cannot achieve this sort of ideal security model because all of your files by nature have to be public. So instead, we need to have either a better web host or our own administrative access to the machine so we can configure this a little more properly. So for instance, what I really want to do now is I'm going to propose the following. Let's steal an idea from Lecture 0 this summer whereby we implement our own virtual hosts. And I'm going to say, you know what, rather than use public HTML, let me give jharvard a vhosts directory for virtual hosts. And in there, I'm going to give him the added ability to do something like this. Project 0 /html. In other words, I'm going to propose that we configure the server in such a way that John Harvard can create a vhost directory inside of which he can create a project directory. Project 0, Project 1, Project 2, foo, bar, baz. Doesn't matter what he wants to call the project. All of his code can then go in this directory. And if you want to secure your website in this more optimal fashion, you just make sure that the web accessible stuff goes in the HTML directory. And your includes directory and your templates directory go where? In here or in here? A or B? OK, B, right? You want them at the same level as the HTML directory, not inside of it. Now, there's a problem here. If I have to edit my web server's configuration for every project this summer, when we get to project 1, what's going to break? Project 0. When we get to project 2, what's going to break? Project 1, right? Because if we keep changing this. And a web server by nature can only have one document root. However, there is a way we can work around this. Let me undo these changes. And let me open up a file whose name is going to change by the time the appliance is posted tomorrow. But I'm going to go in there temporarily to its current name. Let's go into httpd conf.d and pull up this temporary file here. Whoops. Let's look at this file. So this is a modified http.conf. Let me zoom back in to make it larger. That does a few things for us. So let's focus on the juicy part first. In line 7, we have the following comment that I wrote. Virtual host will override http.conf defaults. So what is this saying? Well, name virtual host, whatever that is. Virtual host *80, whatever that is. Use canonical name, whatever that is. And then it starts to get interesting. The most interesting line is 20. 20 is saying that rather than define one document root for the entire server, let's define a virtual document root dynamically by using essentially a variable. So notice what I've done here is I'm saying always look in home jharvard vhosts for your virtual hosts on this server. But this name here can actually vary. It can be project 0, it can be project 1, project 2, foo, bar, baz, whatever you want. But thereafter, always dive into an HTML directory for security's sake. Yeah?
So that means we are creating the number of instances for the IHS?
Can you say that again?
So we are creating the instances of IIHS? I mean, Apache?
So this file will be pre-configured for you. But what it's doing is giving John Harvard specifically the ability to have an infinite number of virtual hosts on the server. So there is one weakness here in that it is hard-coded for John Harvard. However, if we really put some effort into it, we could generalize this further for multiple users. But for now, we just need a single user on this particular VM. And the key is that $0 can represent any directory that we create in that vhost directory. Meanwhile, recall that we saw a logs directory in John Harvard's home directory. Why is that there? Typically, logs are somewhere else on the file system. But for convenience, pedagogically, if you want to be able to access your web server logs, see where you messed up, see what the error message actually is, we've simply told the server, Apache, put logs instead in jharvard's home directory in a folder called logs so that they're accessible to you. And then up here, we see a little familiar syntax. 80 is referring to what, probably? Yeah.
Port 80.
Port 80, which is HTTP. The star represents anything. And what it means here is any IP address or any name. So foo, bar, baz, project 0, project 1. And then name virtual host is just a directive that you need to include when you want to enable virtual hosting based on names in the first place, where the name is inferred from that host header that you get from the browser. So what does this mean in real terms? Well, let me go over here into the appliance, and let me pull up John Harvard's home directory, which again has this. And let me go ahead and make a directory called vhosts, and let me chmod it 711 so that the world can get in there but can't poke around. Let me then make a directory called project 0. And let me go ahead and chmod that. And then let me go ahead and make a directory HTML. And notice I'm doing this very quickly by scrolling up and down. You can go through your history with your up and down arrows. So let me go ahead and make this folder, and then chmod it 711. So now we have a vhost directory, a project 0 directory, and an HTML directory. And let's just do this here. So genie index.html. I am in here. So it's not actually HTML, but that will suffice for a test. Let me do an ls-l. What command should I type to make sure this is actually world readable? Good. Chmod 644. Or I could do the simpler a plus r to give everyone read privileges. ls-l now confirms that this seems to be correct. So now let's go over to my browser and do http://project0/enter. Problem. Chrome was trying to be helpful. It thinks project0.biz exists or .us, but clearly wrong. What's broken here? Got to integrate everything we've talked about thus far from lecture 0 onward. Yeah, something about the host file. So even if you're not familiar with that, roll back your mind to lecture 0. We talked about DNS, and we told the story of going from my laptop to google.com and back, and the various steps involved. And one of the first steps was involved in that process was what?
Well, you can give your local host a name. So
Good, and let me answer the first question first. So one of the first steps involved was DNS, because what's happening here is I've presumptuously created a folder, a vhost called Project 0, but I haven't told the world about it. So I either need to go buy a domain name named Project 0, and that's it, and that's not very realistic, or I at least need to trick my own computer, the appliance in this case, into thinking that a Project 0 domain name exists. Now, I can do this in a very heavy-handed approach by actually editing a DNS server somewhere on Harvard's network or on my computer, but we can do this more simply in a Linux computer or Mac OS or Windows. There's generally a text file you can edit that allows you to do this. So I'm going to type sudo, which is substitute user do, and that means run this command as an administrator by default. And I'm going to go ahead and open up etc for etc hosts. Enter. And that's going to go ahead and open up this file, which looks like this by default. So by default, a computer typically has an IP address that's not public at all. It's called the loopback address, and it is always 127.0.0.1. And that is an IP address that all of your computers have that refers to itself. So it's a loopback in that recursive sense. So if I want to create a Project 0 host name, I can actually just say, all right, well, associate the Project 0 host name with that same IP address. Create an alias for my current computer that's not just called a local host, that's not called appliance, which we, the staff, created, but it's also called Project 0. These are all just now synonyms. So now let me go to my browser and reload this, and voila, Project 0 is born on the internet. Well, not really the internet. Who else in the world can see this? No one at the moment, right? We're not only within the confines of my browser, we're also within the confines of the appliance, and it's the only etc host file in the world that has this change right now, at least. So what happens is that very first story we told in lecture 0 about my computer asks the browser, asks the operating system, asks the world for the IP address of the host name that I've typed in. Now Linux, in this case, intervenes and says, oh, wait a minute, I have that answer for you right here in this text file called etc hosts. Use 127.0.0.1. And then, meanwhile, how does the web server know which vhost to serve up index.html for? Because suppose I had project 1 and project 2. How does the browser know?
But wait, actually, didn't you put inside the project 0 one I am in here, not hello world?
Oh, I did. Damn it. Very good point. That is because, OK, stand by, well played. I had disabled this before class. Notice when you rename a file to .off, that usually breaks it. So let me get rid of that. And now let me do service httpd restart. Oh, you almost let me get away with that. How's that? All right. So now the story is correct. So how does now Apache know which vhost directory to go into to get me an index.html file? Where is that information coming from?
So it's that same file you showed us a few moments before with the virtual host and the directing from port 80 to some project 0.
OK, to some project 0, but how does the server know what vhost was requested? Thinking back to lecture 0? the GET request. So because we've only defined one vhost now, in fairness, but in a minute I could create project 1, project 2. I just have to type make dir a bunch of times. So recall that multiple host names can live at the same IP address. And this is true in the web hosting world and also in our little fake world of the appliance, where we're pretending to be a web hosting company with one IP address and multiple host names. So where is that coming from? Well, let me open up Chrome's developer toolbar. Let me open up the network tab as we've done before. Let me reload this page. Click on here. And actually as a development tip, notice that I got 304, which does not sound good. I wanted to get 200. That's just because of caching. The web server said, you already got this from me. It hasn't changed. Keep the copy you have. So I'm going to instead hold down Shift and reload. In general, clearing your cache or holding Shift is your friend with many browsers. Now I get a 200. And what I care about here is the request headers, which has this key line, reminding the server what host was requested. So we've come full circle to lecture 0. We told the DNS server story then. Now we've actually hijacked the DNS story to insert our own answers to DNS queries. So why is this useful? Why is this relevant? Well, one, as a developer, it's going to allow you for the course of the summer to create 3 different projects on the same server in the same master directory without having to create like 3 different appliances or something crazy like that, or without having to turn off project 0 to turn on project 1 and so forth. And plus, this is also wonderfully representative of exactly what you would find on a VPS, a virtual private server out there, if they do support virtual hosts in this way, and they don't force you to have a URL with a tilde. So even though we started the story with public HTML and tilde jharvard in the URL, that's a hideous URL. Plus, it does not let us implement this more security conscious directory structure. So as you'll see in the spec, for the project 0 and 1 and 2, you will be asked to make sure your site works within a vhost like this, which is perfect because this is the way it should be done in the real world anyway. The only customization we've done is just move the vhost directory into John Harvard's home directory, just so that it's easily accessible instead of being hidden somewhere else on the file system. Whew, that was a lot. Any questions? All right, let's take our MVC one step further before we take a break and then come back on XML. So let me go into the code that we've been looking at. And I think we left off with 5 here, yep, which we had this directory structure. So the website itself aesthetically is not at all different. All we've been doing is hammering on the design. So let me now go into the 6th iteration of this, where I do this layout. Pretty much the same, but I decided, you know what, I'm going to have some best practices here, and I'm going to create a views directory, which represents all of the aesthetics of my site. And I'm going to introduce a slightly different version of index.php that I'm going to start calling the controller. So in this model here, we now have much closer to a true MVC architecture. Still no no models just yet. It's all static content. But now I have a controller, and then most everything else in the views directory is the V in MVC. So let's take a look at how this works and why this design is a little bit cleaner still. In my HTML directory, there's nothing now except index.php. However, if I had GIFs and JPEGs and CSS, it would also go in this directory. But the key point here is that there is only one entry point now to my entire site via index.php. There is no longer lecture0.php, lecture1.php in this publicly accessible directory. Well, why is that? Well, let's go ahead and open up index.php and see what it looks like. Well, in index.php, notice that we have a bit of complexity, but not too syntactically different from what we've done before. So first, I'm requiring this helpers file. Notice I'm using a relative path. This is a common mistake when people ship software that they've developed on their own machine. Never, ever, ever use hard-coded paths that start with a slash, for instance, because it's just going to break when you move it to another server. As best you can, use relative directories so that if you move the whole folder, everything works on another server. What am I doing here? Well, it looks like I'm going to infer from an HTTP parameter called page, which page the user wants to see. So I'm going to store that in a variable called page. And if it's not passed in, I'm going to assume the index, so to speak. And now I have a switch statement, which is like an if, else if, else if, else if statement. And how does this work? Well, if the page that the user has requested is the index file, go ahead and do the following. First, render the header with this title. then render the index with no arguments, then render the footer. And now notice I'm using paths here. I still left off the file extension because it just looks ugly to say .php all over the place. But I did generalize my render function as I had before. Meanwhile, if I instead request the lecture page, actually let's skip down to lectures. If I instead request the lectures page, do something almost the same. The template for the header, render that with this title, then render the lectures template, then rather the lectures view, then render the templates / footer template. So now lecture is a little more interesting. It's always kind of bothered me that I had a lecture 0.php and a lecture 1.php, because even if I'm adhering to these better practices of factoring out the header and the footer, I really wasn't practicing what I'm preaching with lecture 1 and lecture 2 and lecture 3 and lecture 4. Feels like I'm going to get a lot of redundancy eventually there. So I'm thinking ahead now and introducing another parameter apparently called what? N. So just a number, n presumably. So that now my URLs, they might not look as pretty, but we can actually fix that with mod rewrite, which we looked at last time. But for now, just assume that there's apparently two parameters, page and n is only relevant if page equals lecture. But if it is lecture, then I can do this. First render the header with the title of, oh, and this is interesting, lecture space dot n. But we'll come back to this in just a moment. And then lecture n, so render that template with a input of n, and then render the footer. So let's take a look now at these views. Let me go into the terminal window again. There's nothing else in HTML, so I need to go back with ... Let me go into my views directory, and let me open up my index. Well, this one is incredibly uninteresting. All it does is have my main menu. But notice what's not there anymore. What redundancy have I eliminated? What used to be in this file? Very early on, it had an HTML tag, body tag, head tag, title tag, all that stuff. We ripped that out. But what was still left at the top and bottom of every file? Exactly. I had the require statements or the render statements at the top and the bottom of every one of these files. Now that's gone. So my views are even simpler. So that's the index. Well, I had a couple other views. Let me go ahead and open up lectures.php. That's similarly as simple. So that's pretty nice. And now let me go into lecture.php. And now this is kind of interesting because not only is it super short, notice that over here, what am I echoing out? N dynamically. And so long as I've standardized the name of my slides, the name of my movie video file, and so forth, I can generate even that dynamically. But there's a flaw. I screwed up somewhere. What did I forget to do somewhere in this pipeline? There's an XSS attack here somewhere, which again, we'll come back to that at the end of the semester, but we did talk about it briefly last time and the time before. Yeah? Exactly. Exactly. Where did n come from? N came from the get string, and I did not call HTML special chars or anything like it either in the previous file or in this template. So in short, I'm vulnerable to that same kind of script attack where someone might paste in some JavaScript code into my site without me realizing it, which can steal my cookies or other such things. So I should minimally be calling HTML special chars here, or before even passing it in. But frankly, my templates are going to start to look atrocious if everywhere I have HTML special chars, HTML special chars, HTML special chars. So another design opportunity here feels like maybe in my render function, I should first be iterating over the array, escaping everything then, and then passing it into the template. So again, another design opportunity. So bearing in mind for Project Zero, the axes along which we evaluate assignments, not just scope and correctness and style, design is the more subjective of the four, and design speaks to issues like this. If you're copying and pasting the same kind of code again and again, you can take even these lecture examples to the next step, to the next level, and refine them even further. All right, let's take a look, I think, at one last one here. Let me go into 7. And introduce one other trick. Oh, actually, let me open up version 6 to show you how ugly a approach it actually was, MVC. So let me close Chrome's inspector. Let me go into version 6, HTML. Oh, and just to be clear, even though I've chmoded John Harvard's directory 755 for the sake of lecture, so we can click around, realize that if we actually take the vhost approach, it's this HTML directory that could be made to be the virtual host's document root. So again, we're just navigating now for convenience in public HTML. So now notice when I click on version 6's link, notice what the URL looks like. Page equals lectures. That's not all that pretty, but in worse, when I click on lecture 0, then it really gets ugly. All right, it's not wrong. And in fact, this is like true use of HTTP. But frankly, this is Web 2.0 that we're in now, right? And most URLs are much sexier than this. It's just slashes and words, for instance. So frankly, a sexier URL than question mark, page equals lecture, ampersand, n equals 0 would be something like lecture 0. So something like that just feels cleaner. It has no fundamental difference, but it just is the way things are going. And various web frameworks make this easier. So it turns out you can indeed do this with this feature we looked at last week called mod rewrite. So now here, let me go ahead and open up version 7. So let me go back to version 7 here, HTML, and let me click on lectures. And now this is broken because I need to add one other thing. In version 7, we need this here. So we can actually fake those prettier URLs and still use the exact same code by using this tool called mod rewrite. When did we use mod rewrite before? Or why? Yeah. As a redirect. So that was one such trick. And we wanted to redirect from like HTTP to HTTPS, or we wanted to standardize on www.something.com instead of just something.com and so forth. So anytime you want to manipulate URLs, mod rewrite's a powerful tool. So here I have an htaccess file that first turns on that so-called rewrite engine. I now need a rewrite base just for the sake of these lecture examples. Because I'm not in slash, because I'm instead in this silly mvc/7/html directory, I need to trick the server into thinking that where I am is the root directory of the server. And that's just, again, for lecture purposes here. But the last two lines are generalizable. I first have a rewrite rule that says if the user has requested effectively /lectures, and literally just lectures. The caret means start from the beginning of the string. The $sign means match to the end of the string. So if literally the URL is something, something, something /lectures, and that's it, reroute the user's request to index.php question mark page equals lectures, and that's it. So in other words, even though the user came to you via /lectures, actually respond to them as though they went to this partial URL. So this does not redirect the user. Notice there's no R there. There's no 301. There's no 302. This is instead doing a behind-the-scenes internal redirect because there's no HTTP there either. Because it's a local URL, the web server does not need to redirect the user with a location header. It can do it all inside of the web server itself. Meanwhile, if instead the user visited /lecture / whatever this is, now this is just a placeholder. Dot means anything, star means 0 or more anythings. You could then go ahead and redirect the user to index.php, then route the user. Don't redirect them to index.php, question mark page equals lecture, and n equals $1. And what does $1 refer to? Yeah.
Whatever the client typed in after the
Exactly. Whatever the user typed in after the lecture /, hopefully it's numeric. Hopefully it's 0 or 1 or so forth. There's nothing stopping the user typing in foo or bar. So lecture /foo, lecture /bar, in which case they will be passed this page where n equals foo and n equals bar. But the onus then should really be on index.php to just ignore invalid things. We could do some error checking there to make sure that it's only actually a number so that the site doesn't error. Or worst case, we throw a 404 and just say file not found, which would be reasonable as well. So in short, mod rewrite is incredibly powerful and allows you to do these kinds of tricks. And this is very common with things like MediaWiki, with WordPress, Drupal, all of these various sites that you download and can run on your own web server to get these sort of pretty URLs that the world is now familiar with. It generally reduces to techniques like this, because otherwise /lectures /1 would generally refer to like a directory or something like that when it's clearly not the case here. All right, any questions? All right, that was a lot. Why don't we go ahead and take a 5-minute break, and when we come back, we'll dive into XML. Okay. All right, we are back. So you've met Alon and Peter, but I just wanted to introduce a third member of the team who's with us today.
Hi, I'm Chris Gerber. I'm one of your other teaching fellows. I'm an IT manager by day. I work on my master's here at the Extension School at night, and I'm looking forward to working with everyone.
Excellent. Welcome aboard. So Chris will be here tonight for office hours, which will be our first opportunity for one-on-one Q&A about material we've covered thus far, about questions you might have on the spec if you want to take some time either during or after class to read through the PDF that's already online. But toward the end of lecture today, we'll also walk in part through the spec so that you have a sense of what awaits and what kinds of questions you might have. So definitely take advantage of these opportunities in person for help, both in section and office hours. And then for those of you who are distant, as you saw from Welly's note, one of our own distant TFs will also be making available some opportunities online. And even if you're local, you're welcome to tune in to those online sessions as well. So that was a whole bunch on MVC, PHP, Apache. Realize that some of the more mundane minutiae of like typing the commands and whatnot will be recapped generally in the spec as needed. But any questions, conceptually, mechanically, or otherwise? Otherwise, I'll assume you're quite comfortable now with get and post and the session object and MVC. Yeah. OK. So let's forge ahead then into XML, which actually has nothing fundamentally to do with PHP, but for which PHP has wonderful built-in support that just makes working with XML files easy. We will see toward the end of the semester when we look at Ajax and JavaScript, we'll come full circle to some of the same ideas we're about to discuss here. So you'll find that XML is a topic that comes up in all sorts of domains. So here's a simple example of an XML document. Kind of looks like HTML, except again, it's sort of make your own tags. And in this case, we've made tags like order, sold to, person, last name, first name. Everything here happens to be in uppercase. However, lowercase is perfectly fine. HTML typically should be all lowercase these days, but for XML, you simply want to be self-consistent. So this is apparently some kind of representation of what? This is a computer's way of representing what, apparently? Yeah.
Your purchase of the Harry Potter and your Phoenix book.
Exactly. Your purchase of the Harry Potter, which I think is literally the day I bought it from Amazon years ago. So what's your name again? Jack, that's right. OK, so as Jack pointed out, this represents a book that was sold. So why might this be relevant in the real world? Well, it's not so much a data format that someone like Amazon themselves would use for storing data in their own databases. They would need a much faster performance that you would get from something like MySQL or Oracle or a real database engine, which we'll start looking at in a couple of days. But for XML, you might want to, with XML, you might very well use it to exchange data between two parties. For instance, you might use it if Amazon has partnerships with third parties, as they do, to exchange data in a non-proprietary, non-binary format so that if that third party has a database of its own, but it's not necessarily identical or even the same make or model as Amazon's, they can talk in a database neutral way. And so XML is actually very common in the world of RPC, remote procedure calls, a topic generally known as web services or really web-based APIs. And also common these days is JSON, JavaScript object notation, which we'll look at in a week or two's time. So for now, we have some XML. Notice a few key features of it. One, it's hierarchical, at least aesthetically. Just with HTML, you don't need to hit the spacebar or carriage return or anything like that. But if you do, you can see that there is indeed a hierarchical nature to this document. You can see, too, that we have some basic building blocks. Henceforth, something like open bracket, order, close bracket is what we'll call an element. It's not just a tag. An element includes everything inside of that start tag and end tag. So the element here is order, and it has some children, so to speak. So sold to is a child element of order. What's another child of order in this example? Yeah, Jack. Sold on. And you can infer it from the indentation and also from the fact that it's color-coded here. But again, if you actually piece through the open tags and close tags, it is indeed at the same level as sold to, as is item. So apparently the element called order has at least 3 children that we can see here. Now technically, just as an aside, technically order might have more children, even that are pictured here. Technically, there's some white space. Right after order there's some white space to the left of sol2. So arguably, that's another child. And we'll come back to this in a bit. In XML, when you represent an XML document in memory with an in-memory data structure, like a tree, it is indeed the case that white space might matter, even though fundamentally it shouldn't matter for the data transfer here. So more on that in just a bit. So sol2 has a child called person. Person has two children called last name and first name. But person has something else, just like HTML, an attribute with a value in this case, which should be quoted just as I've done here. Single or double quotes are fine, so long as you are consistent. And an element can have 0 or more attributes, but those attributes must be uniquely named. You can't have two ID attributes. So very quickly, we're going to run into a question here of attributes versus children. When or why should you make a piece of data an attribute, do you think, versus a child element? And again, we've only done a quick definition of XML here, but you've been using attributes and elements in HTML for some time. Yeah?
When they're related or unrelated to the other elements.
OK, so when they're related or unrelated to the other elements. So in this case, ID is an attribute because it doesn't really have something to do with first name and last name. And that's reasonable. It's sort of conceptually distinct. So that's reasonable. What else might motivate making ID an attribute as we have here, as opposed to a child element? And to be clear, I mean, what if instead I had not written ID equals quote unquote 1, 2, 3. Instead, after the close brace, I'd hit enter and then done open bracket ID close bracket 1, 2, 3 open bracket slash ID close bracket. So that's all I mean by a child element.
Sorry, should have been more specific. When it's sort of immutable data, it goes along with that child.
Good. OK, so a little different there. So when the data is immutable and really a leaf of sorts where it itself cannot have any notion conceptually of children. So when you are an identifier like a number, a 1, 2, 3, we're never going to be able to tease that apart in the same way that you could tease out a person into a first name and a last name, maybe even a middle name. So there's some notion of hierarchy there potentially. But in ID, that's it. When are you ever going to tease an ID apart into something more if it's just a number to begin with? So in that sense, very reasonable to make ID an attribute because you don't need to extend its definition later. And indeed, that's where the X in XML comes from. It's extensible markup language. And that really speaks to the ability to and explode it into more semantic detail by adding more and more tags just so that you can mark up more pieces of data. In fact, why did I use last name and first name instead of just name, which seems also pretty reasonable? Why have last name and first name here? Yeah?
In case you want to, I don't know, like use the more specific information, whether like sorting by last name.
OK, good. Maybe we want to use that more specific information, like sorting by last name, sorting by first name, or even simple customizations. When you get those form letters from companies, Dear David Malin, feels very cold. And I realize that it's still a machine doing it when it says just Dear David. But at least it's a little more human-like. And it's harder to do that if you just had a name attribute, because there are certainly people out there who don't just have first names and last names. There's middle names. There's 2 middle names, 3 middle names. It's not clear necessarily where the break is between someone's given name and their family name, for instance. So doing it in this way helps with that. All right, so what else is interesting about this? We have tags as are present in HTML, end tags and the like. We have some text. So hopefully syntactically this is all pretty familiar. And it's nice. It's a little freeing in that we can now use our own tags. But here's what I mean about the X, extensibility. Suppose in the future we decided, you know what, we want to go ahead and add a bit more detail to a person. So notice I still have person and last name and first name, but I've decided to introduce the initial, J in my case, for this person, and I also want to insert their address. What's compelling here is that even though the XML document has grown in size, I have not broken the structure of anything that was there before. So XML is compelling in that if this is something being used by Amazon and some random third-party partner of theirs, in theory, if you've written your software well, whereby you expect that XML documents might have more elements than you care about, but not necessarily in such a way that they'll break the document. Hopefully, if Amazon tomorrow decides, you know what, we're going to start giving our third parties middle initials as well as people's addresses, which frankly they should have done the first time, that hopefully won't break any code that other people have written to ingest this XML. Worst case, it will be ignored, the initial and the address, but at least it won't break any existing workflow. And that's one of the salient characteristics here of XML. Well, let's take another example here. So how about a student's database of sorts? Again, not good for long-term storage of lots and lots of students, but for something short, like a pizzeria menu, something like XML might suffice, or even a small database of students. So what characteristics do we have here? We have even more features in this document, which is what it's meant to convey. So at the top here is the so-called XML Declaration. Very tragically, this looks a little bit like PHP because of the dang open bracket question mark. So whereas you can include HTML in PHP files raw and have them spit out, you cannot include an XML declaration in PHP files because it will be confused by the PHP interpreter as being a PHP tag. So instead you have to resort to a hack like using echo or print for this one feature of XML. But just realize there's that corner case. Technically though, the XML declaration is not required. It's simply optional, but it says things like what encoding have you used in terms of character set and what version of XML are you using, in this case 1. So now we have this thing. This is obviously a comment. This is part of the XML spec. You can have comments in it, and in fact when you build up a tree in memory, you wouldn't do this yourself. A browser would do this, or a parser would do this on the server. When you build up the tree that represents this hierarchical document, you will get nodes in that tree that represent comments. So they're ignored typically in terms of rendering. You don't see HTML comments in a page, but they are there, and they are stored in RAM as a node in a tree. So this thing here is the so-called root element of the document. An XML document, like an HTML document, can have one and only one root element. In the world of HTML, what is the root element called? HTML. Right? In the world of XML, it can be called anything you want, so long as there's one and only one element at that level. If you want to put something else at that level, it frankly has to be in another XML file. That's simply the way the spec works. So student is a child of students. It has an ID, in this case, of 0001. Their name here is Jim Bob. Status, a graduate, dorm. This looks a little weird. What does this resemble, and what does this mean, do you think? Jack?
Is it a tag that's opened and closed in its own space?
Good.
He's a graduate and doesn't have a dorm.
OK, good. So it's a tag that's opened and closed all at once, and that typically implies that it's empty. The element can be there, but there's no data for it, so it's an empty element. And here it makes sense that this student might not have a dorm because he's a graduate student. So there's just no address. So maybe this could be removed altogether, but the fact that it's there is not necessarily a bad thing. In fact, the receiving party might prefer that it at least be there to make ever so clear that there is no dorm, not that we forgot to include the dorm. This might resemble an HR tag, BR tag. HTML has empty elements that even though in HTML you don't have to close them with the slash, if you're familiar with XHTML, which is an XML compliant version of HTML, where all tags must be open and closed, attribute values must be quoted, and all tags must be closed even if they're empty like this. Might have seen this syntax before. OK, now we have a major. And here's a curious thing. Why is Jim Bob's major computer science ampersand AMP semicolon music? And what does this remind you of? Yeah, Isaac. OK, it does imply a double major. But what's with this cryptic thing that's never going to show up on a Harvard diploma? Ampersand AMP semicolon. What is that all about? Yeah? The next, not next line, actually. Not a bad guess, though.
HTML entity, and probably because the actual ampersand does something like XML.
Exactly. So this is an this is an XML entity, which is present here because ampersand is a special character in XML. It demarks the start of an entity, and you've probably seen in HTML at least one entity. Ampersand NBSP semicolon, non-breaking space is one special one. In XML, actually there's others in HTML. Ampersand GT for greater than semicolon, ampersand LT less than, followed by a semicolon. There's some special characters in HTML and XML called entities that always start with ampersands and always end with semicolons. And the word between is some identifier. Amp here means ampersand. So even though it's a little coincidental that there's an ampersand followed by AMP, this means that this is an HTML entity representing a single ampersand, which represents the word and. Similarly, if we wanted to put a less than character as part of my major for whatever weird, crazy reason, I would need to do ampersand LT semicolon. So in short, in XML documents, if you have raw ampersands in your document, you must escape them in this way here. OK, what else is interesting here? C data. We'll come back to that. We've got some H1 in here. We've got another student idea. So let's tease these apart a little more specifically. So I'll fly through some of these things just because they're kind of mind-numbing details, but more formal definitions of these various pieces of XML files. So the XML declaration, reminded at top right there, represents, again, an optional piece of data that essentially informs whatever program's reading the XML document, what version you're using, what encoding, and the like. So elements we talked about in the context of the example, but there are a few rules. So one, they always need a start tag and an end tag. If the start tag has attributes, the end tag does not have attributes, just like HTML. There are some constraints on names, which you should bear in mind for PizzaML, for Project Xero. They have to start with a letter or an underscore. They cannot start with numbers, which is one of the minor annoyances with XML, but they can have a few other characters in them as well. And again, so that you don't have to scribble everything down, these slides are on the course's website as always. So content model. So this is something worth keeping in mind because it again allows you to sort of model different design decisions. If you have an element can have different stuff inside of it that is nested inside of it. In the first case, you might have element content, whereby you have an element like student, and then inside of which is another element, in this case called status, and then that's it. So this is so-called element content. You might have PC data, parsed character data. So Jim Bob, that was an example from before too. The child of name in this case is PC data, parsed character data. What does that mean? Well, we'll come back to that in a moment, but for now, just assume it means text. How about mixed content? This is kind of a weird example that you should not do in practice, but it does convey the idea. You have a name element, and then you have Jim Bob, but Jim Bob this time has an initial, and we wanted to semantically tag his middle name for some reason, but not his first or last name. So again, bad design, but it does hint at how you can technically commingle PC data with elements. So this is a mixed content model because you don't just have text, you don't just have an element, you have both intermingled. This is more real if you think about HTML now. In HTML, it's very common to have a paragraph tag, and then you start writing your paragraph. But then in the middle of your paragraph, you enter the boldface tag or the italics tag, and then you close that tag. That too would be a mixed content model. You have text and tags commingled. Then no content, like dorm, like Jack pointed out. So we have those several content models. Those are our options for modeling. Attributes, again, pretty straightforward, very reminiscent of HTML. Must start with letter or underscore and only contain letters and so forth. They must be quoted here in this case. HTML is not as rigorous about this, HTML5 at least, but XML still expects you to quote things, either with single quotes or double quotes. And then again, this last bullet is the most scary. You cannot have ampersands or less than characters. You must escape those with entities. All right, PC data just represents text. So let's fly by this. And now entities. So now we see a more formal definition here. So they're again used to escape characters that might otherwise cause breakages in XML files. In XML, you get 5 entities for free. Ampersand, less than, greater than, apostrophe, and double quotes. And that's it. Only those 5 exist. In fact, NBSP is not on the list. So if you want something like that, you have to define it yourself. And you will not likely need to do this for this project unless you really want to get fancy. This is the syntax in an XML file for how you can declare your own entities. So in the world of HTML, someone somewhere wrote out this entity for non-breaking space. And what does 160 likely refer to? Where does that come from? So that's a decimal number, 160, and that is simply the numeric code that represents the character we know as a non-breaking space. It's not something you can type on the keyboard, but rather that's its numeric code, so it's uniquely identifiable. All right, any questions? And actually, you've seen HTML entities before, right? If you've ever looked up something like a copyright symbol or a weird triangle or circle or some symbol to use in a web page, you've probably used one of these entities, albeit in HTML. So character data is a little different. Recall we had this snippet at the top right here for C data. This will rarely This will not always be necessary, but sometimes is. If you want to have raw HTML or JavaScript or any piece of data that might have scary characters like open brackets and ampersands that it just doesn't make sense to escape. For instance, suppose you wanted, for whatever reason, to store JavaScript inside of an XML file. That's not unreasonable to store a piece of data in another piece of data. But JavaScript has arithmetic functions and things like less thans and greater thans. Right? It would be kind of ridiculous if you had to rewrite your JavaScript code to change things like if x is less than y, then do this. If you had to rewrite that as if x is ampersand lt semicolon y, right? That's not JavaScript. That's a weird amalgam of XML and JavaScript. So CData exists, for instance, for that purpose, where you can tell an XML parser, a program that reads an XML file, much like you yourselves will write, you can say, ignore the following stuff. Do not parse it. It's CData, character data, not parsed character data, PC data. And you can just say to the parser, just suck in everything you're about to see without worrying about its syntactic validity. I'll worry about that. So in this case, I'm using it not for JavaScript, but if you want to store HTML in an XML file, you don't want your HTML tags to be conflated as XML tags, which they could be. Because again, XML, you make up your own tags. Just because they're HTML doesn't mean you can't use the same names for your tags. So if you wanted to include some HTML in an XML document, you have to, unfortunately, wrap the characters with open bracket, bang, open bracket, CData, open bracket, and then at the end, close bracket, close angled bracket. Now, why in the world did they choose those sequence of characters? Probably because no one in the right mind would ever need to or want to type something like that out in the real world, right? It's just, frankly, it took me years to just memorize it, frankly. But now I got it, and it's only something you need, again, in these kinds of cases. So is it relevant to Project Xero? Maybe. If you decide for whatever reason that you want to embed some HTML markup for whatever reason, it could be relevant, but odds are this is not a feature you will need to have since, again, you're writing your XML files from scratch and have full discretion over what to include or not. And comments are as they are in the world of XML. All right. Any questions on the definitions of XML? There's a little more sophistication to it than make up your own tags. But at the end of the day, it's very reminiscent of the HTML world with which you're familiar. All right, so let's now actually use this. I'm going to go ahead and introduce, by way of examples, an API that comes with PHP called Simplexml. It's pretty good. This API is just a suite of functions that comes with PHP 5 that make it easier to parse XML so that you do not need to write software that reads in open bracket, word, space, word, equal sign. You don't have to parse an individual XML file. You can just say, here's a file of XML, or here's a big string of XML. Give me a tree that represents this XML. So there is a function in PHP that comes with this API that will literally hand you a pointer or a reference to the root node of a hierarchical tree that has been constructed in memory. What do we mean by tree? Well, we mean this thing called the DOM. So here's a much simpler example at top left of some XML. Let me zoom in. And notice that it's simple because there's only a few elements here. So just try to wrap your mind around this. We have student's root element, a student child with an attribute of 1, and then 2 children beneath that, called name and status. So what do I mean when I say there's a function that will parse this string of XML and hand you back a reference to a node in a tree? What it means is that PHP, and this function I'm referring to, is going to build up a picture like this here. So at the very top, we have first what we'll call the document node. This is not the root element. So ironically, XML has root elements. But when you build the tree, the root element is not the root of the tree. Now, why is that? Well, it's motivated by the fact that even in my simple example, what did I have above the root element? Yeah, a comment. And that's valid. You can do that. But if you can have comments at the top of your file before the root element, and you want to build a tree out of this thing, you now need a new root for the data structure in memory so that you can hang on to that comment and onto the root node. And so that special root is called the document element, depicted here as a rectangle. So the 2 children of document here, as implied by the downward pointing arrows, is a comment on the left, and then an element node on the right, the element for the student's tag that we saw in the XML fragment. And the order matters, at least when you draw it. Left means it's the first child, right means it's the second child. Now, what are the children of students? I claim that it has 3 children. And just as a sanity check, what are the 3 children of student? Let me put the XML on the screen as well. What are the 3 children of student? And here's where I said we'd come back to this sort of weirder interpretation of children. Yeah, Isaac.
Name and status.
Name and status are children of student.
Oh.
But how about the children of students?
Student, name and status.
1 for 3. So it's not name and status, because name and status are, again, children of student, singular. So there's clearly at least 1 child of students, right? Everyone would probably agree that student is a child of students. But I claim that in some interpretation, there's actually 3 children of students. What are the other 2, Jack?
The space before and after the student.
Yeah, exactly. So you kind of have, we've kind of learned as a species to ignore white space in this case when programming. But notice that this is really a \n. This is probably a spacebar, or \t. So there's some chunk of white space there that the user has hit on his or her keyboard. So if we kind of clump that all together as one chunk of text, that's arguably a node in the tree. And it's what we'll call a text node. And indeed, that's what we've drawn here. The text node here is \n/t. Now, technically, that could be 2 nodes. 2 text nodes, one with \n, one with \t. That would also be legitimate. However, almost all XML browsers should join together adjacent text nodes into just one. So it's safe to assume you'll just get this one as I've drawn here. Now we have the student element, and then over to the right, what should be this element here that's slightly off screen? What's the contents of this node? So it means what comes after student. What's that character I'm pointing at with green? Yeah, Jack? Just a new line. And indeed, if we scroll over to the right, that's what I claim is in that node. Right? So you don't see it because it's white space, but it is in fact there if you hit it on the keyboard. Now, what's the deal with ID? Now, this is just an artist's rendition. But I decided to draw the attribute as sort of a horizontal thing hanging off of the student element. Why is that? Well, it's not correct to draw an attribute as a child, because it itself cannot have children. So I arbitrarily, and just because it fit nicely on the screen, drew the attribute to the right-hand side there instead of down. So that's just fundamentally different. But again, this is just, again, an interpretation of a DOM. Doesn't mean this thing literally hangs off to the right in memory. All right, so what are the children of students? This one's got a lot. It's got some white space, name, white space, status, white space. And at the end of the day, we're going to throw away all of this white space, but realize that truly underneath the hood, there are these nodes having been built up in RAM when reading this XML file. Lastly, it turns out that name itself has a child. And this is one of the real motivations for talking about text nodes. Finally, we have a text node with actual interesting content. JIM space BOB for Jim Bob. That is a child of name, and status as a child of graduate, which is the status of Jim Bob in school. OK, so in short, you have an XML file, either in a file or as in a string variable in PHP. You call a function in the simple XML API that's going to parse that string or that file. What are you going to get back as the return value? You're going to get back the address or a reference or a pointer, think of it however you'd like for now, to that document node that you can then traverse recursively, hierarchically, however you want to navigate this document and pluck out the data. So what's the relevance to Project Zero? You're going to have to come up with a model for your pizza menu, where maybe you have a menu element, and maybe you've got a pizzas element and a sandwiches element or something like that. You're going to need a way programmatically to travel that tree and figure out what types of pizzas are there, what kind of subs are there, what kinds of salads are there, and the like. So this is where we're going with this conversation. So besides DOM, and I didn't even use the buzzword, DOM, Document Object Model. This was DOM. So Document Object Model refers to the in-memory representation of an XML document or an HTML document in this sort of tree fashion. And again, this is something we'll come back to in the context of JavaScript, since it's even more common these days to traverse DOM structures client-side using JavaScript. So let's take an example now. RSS, how many of you actually read RSS feeds? OK, so a few of you. Those are XML files. The root element of an RSS feed is open bracket RSS close bracket, and it's just XML, the rest of it. Now there's a whole bunch of child elements and descendants and some weird attributes in there so that you can store links and pictures and all of that these days. But at the end of the day, RSS is just an XML file, and actually the specification for this language lives coincidentally at the law school, at that URL if you'd like to read up on it. But here's a representative snippet. This is an RSS feed with no actual content, but it shows you the minimum required elements that you must have in an RSS feed. You must have the RSS element at top. You must have a channel element as a child. A channel must have a title, description, and link. And then it must have one or more item elements, or 0 or more item elements, where an item represents a news story, something that's in the RSS feed. And for those unfamiliar, RSS and RSS readers are about syndicating news in a standard machine-readable format so that you can use Google Reader or Safari or Chrome or IE to read the day's news without going to 10 different places, websites, to read them there in their usual way. So an item has a few elements as children. A GUID, which is a unique identifier, which is supposed to uniquely identify that article or that item. A title, a link, a description category, and a publication date. So this is an RSS feed. And let's go ahead now and do something interesting with this. Let me go into the appliance where I have an example here in the XML directory. And let's open up lectures.xml. So in advance of tonight, I decided to make my own XML file that looks like this. A lectures root element, then lecture children. Each lecture has an attribute called number with a value. And then below that is a title and a dates element. And then there's a resources element. And then there's resource, depending on how many resources we gave out that night. And each resource can have a format. So in other words, this is just something I came up with arbitrarily, but I gave some thought to its design so that I'd have minimal redundancy and also the ability to distribute certain handouts in multiple formats, PDF or zip or anything else like that. So for instance, in the very first lecture, we gave out some slides, and here's the URL to those slides. It's a long URL, but it ends in .pdf. We also gave out the syllabus that day. And again, realized that I have put a format element as a child of a resource, simply because if we wanted to release like a Word document for the syllabus, we could, just by adding another format without calling it a separate resource. Same resource, different format. So again, this is representative of a typical XML design decision. So it was to accommodate that kind of versatility. And if we scroll down, we'll see, indeed, here's a good one. Once we get to source code, if you've downloaded stuff from the course's website yet, recall that source code we distribute as an index, which means you can browse it in your browser, a PDF, and a zip. So here's an actual example of distributing multiple formats for the same conceptual resource, in this case, source code. Short, could have done this any number of other ways. My names for tags are completely arbitrary. This is not some lecture standard that the world has agreed on. It's just my little old me's format for XML. Similarly, will you need to come up with your own menu.xml file for this pizzeria? But what I can do now that I have this in XML is something like this. In my XML directory, I have a lectures.php file, which looks like this. For the most part, this is just an HTML5 page with a hard-coded title, and then an unordered list. And here is that function I promised existed earlier. And there's a few variants of this. This is simple XML load file. There's also simple XML load string, and there's a few others. There's also an object-oriented version of this, but I'm using the procedural function. And notice what I'm doing. I'm calling simple XML load file, quote unquote, lectures.xml. And that, frankly, couldn't get more explicit. That is loading that file. What is it returning? It's returning to me a reference to a tree, that hierarchical picture we just looked at. And just to remind myself of that fact, I'm calling my variable $DOM. So now DOM represents the root of that tree. And because this tree's arrows point downward, from that root element, I can access any other node in the tree just by stepping downwards, down, down, down. So how do I step downward? Well, what's nice about the simple XML API is that, frankly, they make it really simple. I mean, that's literally where it gets its name. So here's a for each statement. For each DOM arrow XPath, quote unquote, lectures/lecture. So XPath is XML path language. It's a feature of the XML world that allows you to traverse hierarchical data structures, namely XML files, using paths that look like file system paths, C:\program files, \word, whatever. So using paths like that to navigate a hierarchical document. So in this case, the XPath function always returns an array of nodes that match your XPath expression. So what am I asking for? I'm saying give me all of the lecture elements that are children of what? The lectures element, which is a child of nothing. The leading slash means that's the root element. So if I get back one or more lectures, this for each loop, like we saw last week, is going to iterate over that array. And on each iteration, it's going to update the value of $lecture to be that lecture. And so on each iteration of this loop, we're going to print out an li and a close li, inside of which is going to be lecture title. So this too refers to the simple XML API. If you just want to start at a node and go one level deeper without doing like a search, XPath is allowing me to search the whole tree. But if I'm at a lecture and I want to get a lecture's title, recall that title is its child in the document we just showed. This will grab its title from the node. So if this is a little unclear in code, let's just look at this in a browser. Then we can walk through it. Here we go. That's the XML file. Let me open up the PHP file. Voila. My PHP file has this dynamically generated list of lecture titles, which looks really simple. And underneath the hood, notice, is only HTML. And as I mentioned, disclaimed last week, it's not beautifully pretty printed, because my PHP code is. My HTML doesn't have to be. But all of this came from where? From that XML file. So let's go back to the XML file, lectures.xml. How did I print the title? Well, notice that I used XPath to get all of the lecture elements in an array by saying XPath/lecture/lecture. And that gives me an array of size what, apparently? If you recall from the previous unordered list. How many bullets were there a moment ago? Yeah. There were 4. Why is that? Well, if we scroll through this, we're in tonight. We're at lecture 3, 0 index. So tonight's the 4th lecture. So we have lectures, lecture, lecture, lecture. That's why we got back an array of size 4. And on each iteration of that for loop, what was I printing? I was printing each lecture's title. But what is title? Title is a child of what kind of element? Lecture. So I simply have to say lecture, arrow, title. And that gives me the title. So this is, again, where simple XML gets its name. It's frankly pretty simple to navigate an XML document using these arrows and these XPath expressions, because you can pretty much address any part of the document that you want and really easily loop over it, which will, again, will be useful for dynamically generating a pizza menu on a screen out of one single XML file. Now, what else can we do here? Number. What if I wanted to display the lecture number for each thing? So suppose over here, let me go back to my web page. This is not all that useful because I kind of have forgotten in my unordered list what the lecture number is. So let's go ahead and do that. Let me go in and first remind that number is an attribute and title is a child. So our syntax is going to have to be slightly different. So I'm going to go ahead and do this. Inside of my li, I'm going to go ahead and say lecture. And then I want to go ahead and print out the number. So how do I do this? Lecture, open bracket, quote unquote, n. Or what was it, number or n? Number, quote unquote. And then I'll do like a colon here, just for formatting purposes. So now notice, then I'm going to print the title. So let's see what the end result is. Let me go back to my browser, reload the page, and now we have that. So we have really just 2 pieces of syntax. One is for attributes, which apparently involves square bracket notation, just as though it were an associative array, but it's not really. It's an XML attribute. And the arrow notation allows me to traverse things hierarchically. So it turns out XPath, though, is more powerful. Suppose that for whatever reason, I only wanted to select, for this page, lecture number 3. I need to apply some kind of filter. Now, I could do it the old school approach of, well, just do your XPath expression, get back an array with all the lectures, which in this case is 4, and then just have an if condition. And I could do something correct, but a little tedious, like if lecture bracket n equals 3, then I can go ahead and do something. So I could do that, but it's a little inefficient, and I'm asking for all of the lecture elements, even though I only care about one. So it turns out XPath can do this for me. I can introduce the notion of a predicate with a square bracket inside of my XPath expression, and then I can actually add a qualifier like number equals quote unquote 3 close bracket. And now, if I save the file, and go back to my page and hit reload, I have screwed up because lecture number 3. Oh, because I forgot the attribute. OK, sorry, you don't just say number. At for attribute, at number equals 3. Now let's go back and reload. Whew, there it is. So now I've only selected one node, not 4, with that XPath expression. So let's try to generalize this. Turns out in XPath, you can express yourself in this way. This is sort of the canonical, if overwhelmingly cryptic, definition of what's called a location path. So a location path is that whole expression in quotes. So each of these things between the slashes is what's called a step. Step would be part of the location path here. In this case, there's 2 steps. This one, because there's a slash there, and then this whole thing. So axis, let's come back to. Node test, let's come back to. But here's predicate. We just introduced the idea of a predicate. In this case, I'm filtering on @number equals quote unquote 0, which is hopefully going to give me lecture 0. So now the whole thing is a location path. Now what's an axis? Now thus far, we've been using the default axis, which is child. So if you don't specify the double colons with the word child in front of it, XPath just assumes you want child. But it turns out there's other axes. There's parent : there's sibling : there's preceding : there's following : there's descendant : In other words, you can start at a given node and identify a whole bunch of nodes above it, to the left of it, to the right of it, next to it, below it. Thus far, we've just been doing one level below the so-called child axis, just because it's the most common. In fact, the @ sign here is actually shorthand notation for another axis. And that shorthand notation, when exploded, is actually as verbose as this. So this is identical. Attribute : number equals quote unquote 3. It's just, my God, no one wants to ever type that. The @ sign is a nice shorthand notation for it. However, if I really want to be anal, I can do this really properly. Child : child : and that now is the same thing. So how does this really work fundamentally? Well, when you start an XPath expression and you use it in something like PHP, the first thing says, the slash, give me all of the nodes that start at slash. Fortunately, there's generally only one. There is only one, the root element. So hopefully child : lectures matches the root element. Next, the slash means, OK, start from that result set, that node set containing all of the results of that expression, /lectures, which is one node. And now grow or filter the resulting node set to include also anything that's a child called lecture of the lectures element. It's a node test in the sense that lecture is the name of the node that you want to match. You could change it to a star, and that would give you any children of lectures. I only want the ones called lecture, even though, frankly, there are no other children because I wrote the file. But that's really just a design decision I made. So at this point in the story, I have all lecture elements in my node set that are children of a lectures element that's a child of the document itself. Lastly, you have this predicate. The predicate says, OK, you've got all of these lecture nodes. Now go ahead and include only the ones that match this predicate, whereby their attribute, called number, equals quote unquote 0. And notice a few details here. The 0 is quoted because it's a string. Almost everything in XML is a string, even if it looks like a number, because an XML file is a text file. And the equal sign is a single equal sign. It's not equals equals, as it would be in most programming languages. Also realize you can have multiple predicates. You could have had a predicate here. You could have one over here, and so forth. You just think of these location paths ultimately as these steps that are either adding or subtracting nodes from the answer. And what's returned in PHP is an array of the final results. Whew. That was a lot too. Any questions? All right, so it's time for PizzaML discussion. So in PizzaML, as you'll see in the spec, there's going to be a few components to it. Let me go ahead and open this up in a browser. And the specification for this one, like others, that's what the place used to look like before they shut down, sadly. It's a delicious pizza. What you'll see is that the specs will have you walk through a few steps typically. The little boxes at left are meant to be check boxes so that if you print it out, you can at least physically have the gratification of saying done, 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 done as you walk through the spec. There'll be some recommended reading here that sometimes will teach new stuff, sometimes will recap old stuff, and realize there's plenty of free stuff available. The course's syllabus has some recommended books. None of them are required, so really they're there for your own edification. If of interest, plenty of free content exists on the web. You'll next see in the spec a number of instructions for how to download and install the CS50 appliance. In particular, if you're a Mac user, there is one step you can do tonight. When you go to the URL that's cited in this section of the spec, it has instructions for how to install the appliance. To be clear, the appliance will be posted by morning, but you can download sooner than that VMware itself. If you're a Mac user, you need VMware Fusion. Unfortunately, they only offer a 30-day trial, but we can give you access for longer than 30 days. So go ahead and follow the instructions on the page there, and we'll explain how to get the access to the site license that we have. Windows and Linux users have it easier in that they actually have a totally free version called Vmware Player, which does the same thing, but it's for Windows and Linux, and the instructions are also there. So you can download and install the hypervisor tonight or tomorrow. The Fusion folks, though, will have to wait to hear back from us as to the licensing issue. And the appliance itself will be up by morning. And now we'll have a little more tutorial here on setting up a vhost. So the discussion we had earlier about creating the vhost directory and so forth, all of that is documented here so that you know how to create a project xero vhost. Bitbucket, there's instructions for how to get yourself set up for Bitbucket for your own benefit so that you don't run the risk of losing content accidentally. And then the real guts of the spec, Delicious XML, walks you through the menu itself. So I'm going to defer to Section and to Peter's walkthrough of the same, but you'll see here an allusion to a whole bunch of categories of food which are all present here in the file. So let me pull up here the menu for 3 aces. So this is literally a PDF of the menu that they used to have, and you'll see that they have pizzas and salads and wraps and so forth. But one of these things that's kind of curious is that if you go into the store, you pick up this menu, it's actually pretty obvious to a human how to order a pizza or a salad or the like. But if you're the unfortunate programmer who has to model this same set of data in a database, or in our case, in a simple database like an XML file, you'll realize that these pizza guys really were not being semantically consistent throughout their menu. And which is to say, even though the left-hand side looks like a list of pizzas, all of which are conceptually the same, just pizzas with different options, whoops. If you scroll down further, let me zoom in here. And Chrome is making this PDF look a little weird. Let's open it in preview instead. Let's scroll down now to the menu. So you'll notice that you have pizza with cheese, with onions, with peppers, with broccoli, and then at the bottom, extra cheese. So this is one of these corner cases where this does not belong semantically in the same column of information. Why? Because no one is going to order extra cheese for $1.25 without a pizza. Right? So there's this corner case here that you need to sort of think about, well, how do you tolerate something like extra cheese? Is it a checkbox, a radio button? Is it you type it in the notes? So this is one of those corner cases to run into. Here, too, we have pizza was the header for this section here, and it comes also in small and large. Now notice these are the kinds of things, at least if you're me, you really notice. They capitalize small and large differently here. Down here, spaghetti or ziti is a category of itself, and then the descriptions of the line items are with this, with that, or you can have this crazy thing, which isn't really quite the same. We got homemade lasagna, or so it's things like this. If the category now in your website is called homemade lasagna, ravioli, or manicotti, that's not really just a category, right? That's like at least a radio button between 3 different types of pasta. So again, what looks pretty straightforward to humans, once you start thinking about it as a developer and as a designer, it's not always obvious how you would represent this information. So let's take a quick stab at modeling this data just to get you thinking along the right lines. And then again, with Peter in section, you'll have an opportunity to discuss other design opportunities or watch online after the fact, as well as in office hours tonight with Chris and later on Wednesday. So I need to create a file, as you'll see in the spec, called menu.xml. Now, the design of that file is totally up to you, so long as it adheres to certain bulleted requirements in the spec. So I need minimally like a root element. It could be called menu. It could be called anything you want. Probably shouldn't be called pizzas, because as we've seen, they sell things besides pizzas. So let's just take a group stab for just a moment here. What could be one of the first children of a menu element? OK, so maybe category. So let's do that. Open bracket, category. And now one of the categories, recall, let's go back to it, was pizzas, salads, grinders, then the weird one, homemade lasagna, ravioli, or manicotti. So what more needs to be in this category element? Do I want to close my angled bracket now? Do I want an attribute? Do I want to move on to children? Again, no right answer here, but let's just brainstorm. An attribute? OK, so maybe name equals pizzas. maybe. This not unreasonable. So close category. And then in here, what goes inside of a category? Well, let me look back at the PDF. If it's pizzas, tomato, and cheese. All right, so do I want to say this, though? Maybe size equals small. Right, so this is where it gets non-obvious, right? The XML language is super simple. Children, attributes, that's it. You don't have much expressive capabilities here, but it's definitely non-obvious how to do this. Now, give me an argument against having a pizza element here. Why might this be a bad idea? Yeah.
I mean, if you have multiple categories with pizzas and salads, you would want to be consistent within those categories, so call it like item or
Good.
whatever.
Good. I mean, if we're going through the trouble of sort of generalizing the notion of categories, as we just did, and then refining the definition of a category with a name attribute that is category specific, why are we then hard-coding pizza, which only belongs up there? So we've sort of generalized the category, but then hard-coded the specifics. So maybe better is indeed, let's be self-consistent, and let's maybe say item name equals tomato and cheese, and then I have to somehow embody the notion of size, for instance, and I don't really know how to do that, but I probably don't want to do open bracket large, right? I probably want to do something like size, and then maybe type equals large or something. Again, no right answer, but the fact that I'm kind of pausing and erasing and starting over, it should be the same kind of thought process you probably engage in. And already this is broken. What a wonderful surprise that this menu gave us an example here.
We have an ampersand.
Yeah. So already we have that stupid issue. And this is necessary. If you have this, the simple XML read file function will fail. You'll get an error because it's not valid XML. So I would also make this suggestion. Before you spend an hour or more sort of making your menu, do it in baby steps, right? Write a little bit of code, run it through the equivalent of a program like I just ran, involving the lectures, but using your menu just to make sure that with baby steps, you're not creating a monster of a mess to then go back and fix. So also realize, too, in the spec, this could become incredibly tedious to have to type out this entire menu. So realize that we specify in the spec you only need to do a few from each of the categories. So this won't be an exercise in tedium, but you'll have to trip over some of these design decisions. And realize, too, because we specify in the spec that you only need to do 3 or more items from each of the categories, you can also, in fairness, avoid certain corner cases like the extra cheese thing if you want. That's really up to you as to how you navigate those waters. There's plenty of things to trip over, though, in the aggregate with this whole menu. But let's do one other example now, unrelated to menus, but related to that example involving RSS. So that was our lecture example. Let me go ahead and open up rss1.php, but let me first highlight this URL. Let me first highlight this URL here. My browser not cooperating. Do it this way. OK, there we go. So first let me copy that URL. Let me then visit it in my browser. And here's the problem with RSS, at least from a developer. This is not the RSS feed. This is the browser's rendition of an RSS feed in a more user-friendly way with stuff that's not in the actual RSS file. In fact, if I view the source of this, odds are, depending on the browser, I'll see HTML, and I won't see RSS. So there are ways around this. Let me actually open up my terminal instead. And what I'm going to do is this. I'm going to type wget for webget. Then I'm going to paste in this URL and then hit enter. What's nice about the wget command, which exists on a lot of platforms like Linux, is now I have a file called technology, and here is the RSS file. Now, the specifics of this RSS file are not all that interesting for us tonight. Realize that they do adhere to the pub date and title and link and description, all those placeholders I promised existed in an RSS file. They're in this one as well, in addition to a bunch of other stuff. Atom is an alternative file format, and there's namespace support in this thing. But in short, at the end of the day, this is an RSS feed. And it has channel and item and item and item and item. Suppose I wanted to implement my own RSS reader. Well, think back to the format that an RSS feed has, which again looks like this. And knowing just this, I should be able to write this RSS reader pretty easily. Let me go to my rss1.php for a first pass at this. Here, as I claim, a super simple RSS reader. This time I call Simplexml load file, and you can actually in PHP pass URLs. Generally anywhere a file is expected. This has to be enabled on a system, but it usually is by default. But if it's a URL instead of a file, the function Simplexml load file will use TCP/IP and HTTP to go get the contents and then treat it as though it were a file. Now here's my RSS reader. For each of the item elements, that's a child of channel, that's a child of the DOM itself that was returned by parsing that XML file at that URL, go ahead and print out an li tag, followed by an anchor tag with this href. Now here's slightly new syntax, but you can probably infer what's going on. PHP supports variable interpolation, which means if you have double quotes and you put a PHP variable inside of them, that variable's value will be put there. By contrast, if you use single quotes, that will not happen. However, when you have weird syntax like arrows, so it's not just $item, you want $item arrow link, you need to make clearer to PHP what should be interpolated. For that, you use curly braces. So notice I'm using double quotes there and there. But because this is kind of a funky looking variable with the arrow notation and whatnot, I need to put curly braces around it. And those won't show up in the output, but they will tell PHP, interpolate this. And to interpolate, again, means replace this variable with its actual value. Now, the fact that there are single quotes there is just a coincidence. That does not mean the variable won't be interpolated. The quotes that matter are the outermost ones. And in this case, they're double quotes. So in PHP, using double quotes when you want to put variables inside is necessary. All right, after I've printed out that anchor tag with an href attribute, I just print out the title. Then I print out the anchor tag, then the close li tag. And then the rest of the file is close body, close HTML. And now, if I pull up rss1.php, which I can do here, rss1.php, we didn't look at them, but there is a super simple RSS reader for today's, literally, New York Times feed, whereby I just visited rss1.php on my own appliance, which is running Apache. Apache has PHP support installed, which means there's a PHP interpreter there. Web server realizes you want rss1.php. It says, oh, let me pass this file to PHP's interpreter on the local computer. The interpreter reads my file, rss1.php, top to bottom, left to right. As soon as it hits the line Simplexml load file and sees that URL, my appliance makes an HTTP request to the NewYorkTimes.com, gets back the XML. It gets parsed by that function. Then my loop happens. So all of this happens behind the scenes in what, like 6 lines of actual code? And I have my own RSS reader here, spitting out the titles and the links. So it can be as simple as that. So what's the point of this lecture example? What's the point of this RSS example? Really to give you the basic building blocks with which to create and then traverse your own menu.xml file. But to do that, ultimately, that's just one piece of the puzzle. You'll need to have some notion of support for sessions, right? Because if a user wants to not only see the menu, but click links or fill out forms adding things to his or her cart, you're going to want to remember what pizzas, what salads they've added to their cart. So what super global is appropriate there? Yeah, $_session, so you'll need to make use of that. You don't need to have logins, so the spec does not require usernames and passwords or anything like that. You don't actually need to send the order to a company, the store. You just need to confirm for the user, and you can fake for the user that their order has ultimately been submitted. But you're going to have to maintain some notion of a shopping cart and enable the user to add and remove things from that cart. So ultimately, you'll probably have a few different pages, unless you use one main controller and have multiple views that the controller uses. But again, this is the key aspect of the design component for the project. There's no one right answer here. You're welcome to bounce ideas off of us on the discussion board, whose URL is in the spec and also on the course's homepage. But there's a lot of pieces now from lecture 0, 1, 2, and now 3 that you can hopefully start to wire together in the interest of making your own pizza ordering website. And along the way, hopefully you will trip over a non-trivial number of annoying data issues, which are going to be representative of a class of problems that are out there in the real world when it comes to just making stuff work for companies like this one. Any questions on XML, PizzaML, or the like? Yeah?
Is there any difference between using XML and PHP for a pizza menu? Like if you use PHP like how you did in header and footer instead of using XML?
Good question. Is there any difference between using PHP and XML for the menu? Really, it's separation of data and logic. In theory, you could represent the menu somehow with a whole bunch of variables in PHP, or even a massive PHP associative array. But that's not very easy to maintain. And it also doesn't allow you to semantically tag information as much as you can with XML, which again has child support, which has attribute support and the like. And the short of it is that it's just wrong to model data in that way in PHP, since the data should transcend the particular choice of language. So another argument in favor of the XML file is now it's much more portable, can be read by different languages and the like. And so it's just a cleaner way of doing it rather than hard coding things for PHP. And moreover, what it will allow us to do longer term is once we introduce an actual database like MySQL, then you can leave most of your PHP code the same and just change a few lines that relate to the XML file and plug in support for MySQL instead of XML, and everything just keeps working. So this separation of data from logic allows you to sort of refine and build upon it longer term much more cleanly. Good question. Any others? No? All right. So that was a lot. When we call it a night here, I'll stick around for one-on-one questions. Peter's going to get set up and then dive into the walkthrough of the spec itself. Otherwise, I'll see you on Wednesday.